Hi everyone, in this video we'll talk about the electric power plant. The first one we will talk about how does the power plant work.
Okay, now I will explain about how does an electric power plant work. Most electric power plant have some common what do I have? What's the word? Oh, common components such as a boiler unit, a turbine generator, and a cooling system. Now, this like when speak in this picture. Now, let me explain about are the components and how do they work and how do they actually influence an electric generation. First, um, there is the reactor vessel, or what in this picture is called the reactor vessel, or what could be we also said as a boiler room. So first, water from outside of the power plant, usually from reservoirs such as what rivers or lakes they are near this power plant, are taken and then sent from a pipe to the boiler room, the boiler unit. Now, the boiler unit generates heat differently depending on what type of electric power plants they are. Fossil fuel power plant uses obviously fossil fuel, natural gas, and coal. Nuclear power plant use the heat created from nuclear fission, or the splitting of atoms, which created a lot of energy and heat that is used to boil up the water. Some, such as, yeah, that's all type of nuclear reactor that actually uses heat. Others are like maybe geothermal power plants that uses the heat from the Earth's core to generate heat. But all of these are actually used in all the heat are actually used in for the boiler units, which actually heats up the water and turn them to steam. And this steam inside the boiler unit are actually pressurized because the boiler unit itself is pressurized to be multiple times the pressure of Earth's own atmosphere. So this entire pressure steam is then pushed through pipe into a turbine, the turbine generation. The steam then, the superheated and pressurized steam, then push the turbine blade inside the turbine, which then move the generator's own coils inside them, and a coil there is copper coil that is actually been close enough to two magnets, which then generate the electricity. Now, the steam that is already been from here, from the turbine, have to be condensed or turned back to water. Now, that is where the cooling system actually comes in play. The cooling system can be both from maybe a water cooling system like um, from the water inside being circulated and evaporated, and maybe some can be just dumped into cold water from the reservoir and taken out. And this is actually why some electric power plants actually generated, not generated, they expel or the water coming out from the power plant are actually 10 to 20 degrees hotter than the water itself from when it was intake. Now, I will explain about the thermal systems, which are the fluid mechanics and the heat transfer. Now, the heat transfer of an electric power plant is actually quite obvious, which is the water that is changed from water to steam, and then from steam condensed back to water. So the heat transfer is the energy that is from the water, from the burning of coal, burning of fossil fuel, natural gas, heat from geothermal fans inside the earth, or even from nuclear fission are actually converted and to change water from from water to steam. Now, the steam is then is pushed to a turbine. Nah, and that turbine, after the steam has done its work in the turbine, it have to be condensed back to water. So there's cool water from outside, or the water is, or the steam is, how should I say it? The steam is circulated up inside a huge chamber to cool it down. This chamber is to cool down the water or let the water evaporate. And that is where the cooling system play. And that is why the cooling system is important inside the power plant for heat transfer, so that the power plant doesn't overheat and melt and cause a meltdown. Even normal power plants can have a meltdown, but they are less severe than a nuclear one. Very, very less severe. For fluid mechanics, it is the water inside the cooling system and the water that is coming and the steam. They are the fluid mechanics inside the power plant. This fluid mechanics can be either when the water moves inside the power plant, or when the cooling system works, or when even such as when the water flows inside the boiling unit. The fluid mechanics are actually simple because they are actually moving water into steam, and then the steam, because of the pressure, is then pushed to to a tube or to a pipe into the turbine, and that is why there's the fluid mechanics. Next will be explained by my friend.
The thermodynamic of the electric power plant is very similar to the Carnot engine or heat engine. As you can see, there are a schematic diagram and the diagram. It looks like a Carnot cycle. So the Carnot cycle or theoretical thermodynamic cycle is proposed by Leonard Carnot. It We can estimate the efficiency that a heat engine during the conversion process. So there are two reservoirs. In this case, we have the hot reservoir and the cold reservoir. So from the transfer from the hot temperature to the cold temperature, they are exchanged and there are results. So the result either waste or we can turn it into a work. So the heat is equal to work. Thank you for listening to the end. We just barely explained a little bit about the thermodynamic of the electric power plant. I think that's all. Thank you for listening.